Hi everyone, and welcome to the Achieving the Lowest Cost for Every Ground Mount Project webinar. Thank you for joining us. My name is Yuri Reznikov. I've been here at SunLink for almost 4 years now, and I run the products team. We're responsible for launching the products that you see from SunLink, looking at the roadmap, innovating on the feature sets, and launching new products.
Hi there, my name is Kate Trono, and I am part of Yuri's team in product management, and I lead the ground mount efforts here at SunLink. My background is in structural engineering, so I started out at SunLink developing a lot of the structural analysis methodologies that we use for our ground mount products, and now I'm working more on the whole ground mount spectrum.
Great, thanks, Kate. So today we'll talk about a couple of things, but I'm assuming everyone joined here to discuss how to optimize their ground mount projects. We'll focus this webinar specifically on the product and on the mounting system. We're not going to talk about SunLink products specifically until the very end, but try to give everyone an idea of how they should be thinking and what questions folks should ask when really designing a project, looking at different mounting vendors, and just really understanding what goes into designing an effective and producing an effective ground mounting system. So every ground mount project is unique, and I think that's a pretty common assertion, and there's different challenges. The top 3 ones are listed here. So what we typically see is foundation challenges. We don't know what's below the soil. We don't know what kind of posts will be required. Even if we have a geotech report or a soils report, even if we do a pull test, meaning we go out there on site and test the resistance for individual posts, we still don't know what the entire site looks like. We still need to take that into account. We're designing the system on top of the posts and really understand how those two things, the mounting system and the foundation design, correlate to one another. There's also the environmental conditions. When we talk about wind or snow or combination of those, in California, seismic conditions, for example, we need to be really creative in terms of how we design the system with respect to the different components that are used, to the post spacing that we do, depending on the loads. One design for certain environmental conditions for wind is not going to be the same for snow, and it'll be very, very different in the extremes. And then the third is layout considerations. So where's the inverter going to go? What does the site plan look like? What is the maximum row length that we can allow? How is the installation going to be done? So do we need aisles? Do we need walkways, etc.? And depending on how that layout is shaped, there's different design considerations that we should take into account as well. So in summary, a system that you may have used on one project and that worked out great may not be the same or may not be the ideal system to use for another project. And that depends on these things that we've just discussed and others that we'll get into as well. So in summary, what are some of the questions that we should ask to make sure that you're picking the right system? In today's webinar, we'll go over a couple of things. We'll go over how should you think about post spacing and what affects post spacing, and how not only optimize post spacing from a materials perspective, but also to make sure that you have the lowest cost in terms of labor. Environmental optimization, we'll get into this in terms of optimizing for wind. We'll talk about external versus interior optimization so that the exterior arrays provides shielding from the wind, so we can optimize those two things separately. And we'll talk a little bit about other considerations with respect to wiring or combiner box mounting and some of the accessory things that you should think about when looking at a mounting system. Then we'll briefly discuss SunLink's ground mount products, and we'll have time for questions and answers. You should also know that you can submit your questions through the chat window in WebEx. We'll try to get those questions answered if it's appropriate, maybe during the presentation, but most likely we'll just leave all the questions towards the end. And now Kate will walk you through the first piece.
Great. It's a little tight.
as you start looking at your project and you're evaluating both the racking and the foundation piece of your project, you want to look at what post spacing is going to provide you with the lowest total installed cost. And so the two things that you want to look at your foundation for are the post spacing and then the post length. As your post spacing increases, your loads on each post are going to increase as well, which, depending on your soil conditions, could have either a minor effect on that total post length, or it could be something that's prohibitive, depending on the type of mechanical installation you're going to do, the type of equipment you have to install those posts. Too long of a post might actually be impossible to install on your site. And so evaluating those pros and cons between increasing or decreasing post spacing and then that post length that will result from that is important as you're looking at your total project. So here we're trying to look at two options is really the way that we usually think of it. The first option would be maximizing that post spacing, which is shown on your left-hand side, and then determining your resultant component sizes after that post spacing is maximized for your project. And what that gives you for each project is the fewest number of foundations on your site, as well as the fewest number of foundation attachments. So however your racking is attaching to that post, which is often an expensive piece of your racking system, that will be minimized if you're minimizing the number of posts you have on site. However, what you're allowing with that optimization pattern is larger component sizes spanning from one post to the next, and also, again, potentially longer posts. Your option 2 that we're looking at listed on the right-hand side minimizes the component sizes that are spanning from post to post, and then determines the post spacing in order to achieve those smaller component sizes. And so again, this is allowing you to use, really optimized very small component sizes and possibly shorter posts, but it is going to allow for many more foundations and foundation attachments. And depending on the difficulty of the soil at your site, that could be cost prohibitive in your total installed cost. And so what you're looking at to optimize foundations is really the number of foundations and the length of the foundation. And those two patterns might be contrary to each other. So you need to evaluate the pros and cons of both optimization routes. And then on the racking, you're looking for the fewest number of components as well as the smallest number of components. So again, depending on your post spacing, how far that these components have to span, those optimization patterns could run contrary to each other. And so to find the least expensive racking, you really have to look at both options and evaluate them both. So here at SunLink, what we're trying to do, we're taking in some basic project parameters which are listed in the table. Your tilt angle and your leading edge of your system, because those are parameters that are affecting the wind loads that we're getting from our wind tunnel data. And then the wind velocity and snow load obviously are directly affecting the quantitative analysis of your loads on your system. The module size, which is important for determining how many modules you're going to span between posts, what your total tributary area is of your panel, and then a couple other wind and seismic parameters that just affect those loads. And what we're doing then is we're taking these inputs and looking at both optimization patterns. So we're actually running through an automated process that designs the full system from a structural perspective for both maximizing post spacing and minimizing component sizes. And then we're able to really get a good picture of the pricing for both the racking and potentially, depending on the state of where the geotech is for the project, what the foundations could look like for both options. And so what we're doing here, we're taking those project inputs and then we're getting both options out, both the total price for both options and the component sizes. And then what's really important here, even if we do the racking analysis for both optimization patterns based on the project inputs and the site parameters of your specific project, it is important then to note that depending on where that geotechnical analysis is at the stage of project you're looking at, we can provide a top of post load report, so the loads at that interface between your racking and your foundation. That's an important gateway of communication between the racking provider and your foundation designers. But until you have a final foundation design, so whether that's through a geotechnical report where you have design parameters that are given by your geotechnical engineer, or if you're going to do push and pull tests after you've finalized all of that testing and you've confirmed that your post is within the size length that you can allow for with your installation patterns, and that your total installed cost is minimized with that foundation design, you really can't confirm your project specs until you have all of that together. And so finding matching those two up is an important part of your project. And the convergence between that preliminary system design and then the final foundation design is often an important part for firming up your final project pricing. And oftentimes at this stage, if we do go through the process and determine that the racking is best cost optimized for one optimization pattern or the other, it's very important then to look at what how the foundations will affect that final price.
Sounds like, Kate, we have quite a few questions. Let's try to answer at least a couple of them before we get on to question number 2.
Okay, so when we're looking at how many modules we recommend spanning between the posts, we're looking normally at a four module and landscape configuration. And for our normal sort of California wind zones, in the interior zone, we like to see three modules, so 3 4x1 panels spanning between posts in the interior zone, and then 2.5 spanning between posts in the exterior zone. So that allows kind of that greatest post spacing to be achieved while also accounting for the rails which are supporting those modules to never hit on a post gap. We're also looking at another question here is what is the top of post load report? And what that is, what we're looking at, we percolate all of the loads down from the module level through the components to the top of the post. And then we find that final axial load, shear, and moment force at the top of post. And usually geotechnical engineers are wanting to see those in unfactored ASD loads. And so by giving that to the customer and being able to show that to the geotechnical design team, we're able to communicate most effectively on what the foundation design should be as it meets the racking design. Another question here, what type of soil is most difficult? Various soils are challenging for different reasons. When you're looking at your axial capacity of your post, sandy soil is often the most challenging. It doesn't provide as much axial capacity as some other soils, and so that is where you're usually seeing that increased post spacing really affecting how long your foundations would be in sandy soil. And then other soils can be more or less challenging for other reasons. For instance, a rocky or cobbled soil is very challenging to drive posts, and so then your post installation price will increase significantly if you have to drill and drive, or if you have to grout around your post, which then usually because your per post price is so high, by increasing post spacing and minimizing the total number of posts on a project, you can really save a lot of money on those types of projects. Okay, so now we're going to get back to our question 2. Can we optimize exterior versus interior zones of the array to lower total installed costs? So the way we here at SunLink are doing our wind tunnel test is a boundary layer wind tunnel test, and you can see some images along the left-hand side of the slide, which is a pressure tap wind tunnel model where we actually are measuring the pressures at various points along our array as the wind is blowing through the wind tunnel. And then we're able to find the maximum pressure that's seen at each point over time as the wind is being applied from 0 to 180 degrees in 10-degree increments. So the wind is being applied from the north of the array along the edge to the south of the array. And the pressures then that are gathered at each data point are then area averaged. So what we're looking at is for a rail, which is supporting a module, that's seeing a much smaller area of load, and so it's more susceptible to the effects of localized gusts. And so we're averaging the pressures over a smaller area and then applying that load to a rail, whereas a purlin, which is spanning between posts, is taking load over a larger area. So it's a bit less susceptible to localized gusts. And so we're averaging the area that the pressure taps are measuring for a larger area for the purlin type component. And then as we gather the data from that wind tunnel model, this is kind of a picture just to visualize what those pressures are looking, the red being the highest wind pressure, the blue being the lowest wind pressure over the array, just for one test of down push for a 15-degree, 24-inch leading edge system. And we can start to see trends as we look at these pressures that are measured at each location, where the south row obviously is seeing some very high pressures compared to the interior of the array. And as we start to distill this data down, we look for the maximum pressure that's recorded in each zone. So we specify our zones as being the north row, the north second and third rows, the east-west edge, the south row, and then the rest of the zone, the interior of the zone. And we're taking that maximum area average pressure that we see in each of those zones and applying it to the entirety of the zone. And so then what that results in is a project layout that typically consists of two zones or two designs. An interior array design, which has an increased post spacing or a decreased component size, depending on which optimization pattern ends up being the best for your project, as well as an exterior array design, which has a decreased post spacing or increased component size. And what we tend to see is that by distilling this down into two designs rather than maintaining all of the different zones and having a different design for each zone, we're able to achieve more volume pricing and a more streamlined installation by not having so many different component sizes and just two. And there's a couple considerations that should be discussed along these zoning and layout guidelines. One is row spacing. By looking at what the actual spacing is from row to row, and especially with when you're taking into account the location of your inverter pads and your road width, then that spacing from array to array or from row to row can affect whether you can maintain interior zoning by saying that the array is still shielded from row to row, or if you have to move to an exterior row because your spacing between rows is too great. For instance, if you have a fire road, your exposure on the rows that are adjacent to a fire road might be so much so that you have to say you're back to an exterior zone. It's also important to look at your row length, your overall row length, because you want to optimize both for your post spacing increments in your various zones if you have different post spacings. So for instance, if you're spanning 3 modules or 3 panels, 3 4x1 panels between posts in the interior zone, and you're spanning 2.5 panels between posts in the exterior zone, you want to find an increment of panels as your total row length that will maximize your ability to use that post spacing throughout the row. And you also want to optimize for string length. So you want to make sure that each row has a finite number of strings so that you don't have to trench between your rows. So this is just one project example to give you a little bit of a sense of how these things can affect your project. So looking at just a 90C, 0 PSF snow, so this is kind of typical California conditions. For a racking price comparison, we're looking at one system at a 15-degree tilt and one system at a 35-degree tilt. And at a 15-degree tilt, by maximizing your post spacing, you're actually slightly lower price than by minimizing your component sizes and allowing your post spacing to decrease. But at 35 degrees, your price for your racking would increase slightly for option 1 compared to option 2. So what that's just showing is that, because you're changing two things at the same time, you're changing those component sizes, so your purlin depth, your rail size, you're changing those component sizes while also changing your post spacing. It's not directly linear. There's not one solution that's always cheapest for each project from a racking perspective. But then as you start going into those foundation determinations, and this is why it's so important to be really looking at your total installed cost when you're evaluating a project, is that as you are determining that foundation piece and how expensive that might be, by holding the post length constant for this analysis, just because we wouldn't know the exact post length for each option, it would depend on your type of soil. If your post length is constant, then the option 2, where you're minimizing component sizes but allowing post spacing to decrease, that would be a 1.2 times cost for your foundation over the optimized, maximum post spacing option.
Okay, we have a couple more questions that just came in. We're getting quite a few questions, and we'll try to get to some of them, more of them at the end, but it's probably a good idea to respond to some of these right now.
Okay, so the first question here, what is a leading edge? A leading edge is the distance from the lowest point of the lowest module to the ground. So what we're usually seeing are ground clearance distances, so those leading edge distances of around 12 inches to 36 or 48 inches is kind of standard for most projects we're seeing.
And that would affect the design as well. So anything that you would consider moving north of 24 inches, going to 36 inches, the wind loads, that leading edge would increase. Your post length would increase as well. So there needs to be some consideration given to why a certain leading edge is necessary, whether it's a certain ground clearance or it's the terrain type or lawnmower considerations. But we typically see in the 24-inch range of leading edge.
Another question here, can you have more than 2 designs? You can, and on really large projects, occasionally we do see that does provide some cost savings. But because we like to optimize not only for the actual material savings, but also for installation practices and ease of constructability on site, it's usually simplest and most cost-effective to limit a project design to or a project system to just 2 different designs.
Great, thanks, Kate. The other piece, as I mentioned earlier, we wanted to review is to take a look at some of the other considerations with respect to mounting systems. And primarily this is one from an electrical standpoint. So the first thing that we want to discuss is stringing. There's a couple of different ways that you can string an array. These examples on this slide showcase just 16 modules, but you can imagine if it's a longer table or if it's a continuous system, this is just one particular section. In example A, we have the up-down stringing. The string is 16 modules, and the red line represents the stringing path. That's a fine path, except to where if you have the southernmost row of modules shaded, you're basically blocking out the rest of the modules and you're not getting any energy production because of the way it's strung. In example B, you have a little bit of the opposite situation where you're stringing it all the way across, and if the southernmost row is shaded, the other three strings perform as necessary and still produce energy, which is ideal. One thing to consider is that you're limiting your row length to the string length. So if your string length, as in this example, is 16 modules, in example A, your row length or your table length would be 4 stacks of 4 modules. In example B, it would actually be 16 stacks of 4 modules. And then we get into example C, which is a little bit of a hybrid. And what that allows you to do, you still have your row length of, in this example, it would be 16 modules. You still have the benefit of the bottom row, if shaded, the other 3 rows produce energy. And when you're pre-panelizing these modules, which is basically with our design, you're putting the modules onto 2 rails and then putting those 4 modules onto the table of the system, you're able to connect at least some of those panels together, again, saving on-site labor and making it a little bit more efficient. So we see most customers actually go to design C versus A or B. But again, it depends on what the priorities are, what kind of inverter you have, what your labor costs are, etc. So we typically like to work with the installer or developer to optimize this. The other thing that most folks need to consider, and this is fairly common, is grounding. Grounding every module on a large project could be 5 to 7 cents full of copper and labor, and we're typically not seeing that in the industry anymore. What we are seeing is integrated grounding through ETL or UL 22703. A few number of years ago, folks used to use weaves or certain attachments to create this. Now most racking manufacturers certify the clamp to that allow for integrated grounding. And what the clamp does is it creates a little pattern in the module and penetrates the anodization layer to create bonding between the clamp and the module. What we need to take into account is to say, now that you have the clamp listed, what about the rest of the system? How is the clamp bonded to the rail, to the purlin, and all the way down into the ground through the post frame? And that's important because if you have nothing to certify that that is in fact true, you may have some permitting issues, or you may have some questions being asked that may be difficult to answer. So we recommend to make sure that the mounting system has tested the entire chain from a bonding perspective through ETL or UL or another testing facility to UL standard 2703. You can see in the bottom right-hand side, there's a picture. The red line represents the grounding path going all the way from the module to the rail, through the purlin, to the post frame, to the clamp plate, and into the post. And this way you can be sure that the entire system is mechanically grounded into the ground and continuously through the row. The other piece that is not critical, but again, when we're thinking about optimizing installation costs and we're thinking about optimizing product costs, there are some synergies between combiner boxes and mounting systems. And the synergies really lie with respect to mounting. We see a lot of folks build separate structures off to the side or in the middle of the array using some sort of unistrut, placing the combiner box on there. At SunLink, we think that that is too much effort, too much work, and we have simpler solutions. And this is one of the things, again, that you should ask the mounting system vendor in terms of how do we mount these combiner boxes? What's a quick and easy way to mount them? We provide brackets to be able to mount the combiner boxes. They hang on, you mount them with 2 screws, and you call it a day. A couple of different versions here. On the right-hand side, you're seeing one mounted to the purlin, a little higher off the ground, and creates a nice access. Some folks prefer the combiner box mounted on the post. We have a solution for that as well. And the combiner boxes, we make sure that the enclosures that we provide are compatible with the brackets, so it simplifies the entire installation process from that perspective. And last but not least is integrated wire management. This is one of the most common things and themes we hear is how do we do wire management with your systems, please provide a solution, whether that's clips or at least some sort of a methodology for doing wire management. We've heard in some cases this is 20 to 30% of the labor cost of the mounting system to just do the wire management and run wires, and whether that's drilling holes in the system or putting wire ties or buying special clips. This is something that needs to be thought through before going out and purchasing a mounting system. The example I'm showing here on slide 28 is really looking at the east-west runs. We're using C purlins. So we're providing the holes in the purlin so that you can use a clip or a wire tie. We're recommending certain locations for wires depending on how you want to run them. We're also providing certain holes in the rails so that you can run from the module to the C purlin all the way down to the combiner box area in a nice and easy and, again, cost-efficient manner. Now we want to review some of SunLink's ground mount products briefly. I won't spend too much time on this, but I wanted to give everybody a little bit of insight on how we think about our products and what our products look like. It's a very simple product. We have about 6 components. The modules are pre-panelized onto the rails, which means you can do parallel installation while the crew is installing posts, putting the post frames and putting the purlin onto the system. And the other crew can be working in a tent in a controlled condition, putting the modules onto the rails, at which point the pre-panelized assemblies can be brought out on site. We provide a methodology and actually jigs, whether that's a lifting jig, so you can mechanically lift these panels onto the purlins, or you can have 4 to 5 folks just basically slide them on there. The rails have hooks, and so you can just lift that up, leave the modules or the panel in place, and then someone from the back can go and tighten that up with a simple clamp. The other system is a ballasted system. So this is a system that can be used really on landfills or brownfields, or where penetrating the ground is frankly either impossible or very, very expensive. It's a simple 1x9 system, or I should say 1 in portrait, with 8 to 9 modules between the different A-frames. We're keeping it low to minimize the ballast, minimize the wind loads, and doesn't require any sort of ladders or installation techniques. Everything can be done at eye level. Has plenty of adjustability for differential settlement. It is not connected east-west or north-south, again, to make sure that if anything happens in terms of settlement or these blocks move in some way because the ground changes positions, you're not necessarily pulling or pushing anywhere on the array. But again, very, very simple system. We're providing integrated wire management on this system as well, and it goes together very, very quickly. I should mention we have a couple of other products. This webinar, again, is focused on ground mount, but we do have a couple of roof mount products. SunLink does a lot of work in flat commercial roof mount. We have a core RMS in the upper right-hand side. Very simple system to install. It's steel galvanized G90, and in the bottom left-hand side we have the precision RMS, all aluminum, a little bit of a higher-end product for some of those higher wind or snow loads. We also have a line of combiner boxes. There's I believe about 1,500 different SKUs in that line to make sure that we have the combiner box that fits your needs. And once we integrate that together, as I mentioned, the mounting system and the combiner boxes with the mounting solution, it creates a very low-cost, efficient solution. And let's see if we have any questions. Can any vendor's combiner box be mounted to your system racking, or only your combiner boxes? That's a good question. So our combiner boxes are designed to be compatible with our brackets. We take great care in picking out our enclosures and modifying them as necessary to make sure that they fit the brackets. If there is a third-party combiner box that has the same placement of the holes in the enclosure, they should be compatible, but you're all going to have to do your own due diligence to make sure that there is some compatibility there. We can guarantee, obviously, that our combiner boxes are compatible. And then another question of How can I determine if the system is certified as grounded? Well, you want to make sure that the system has an ETL or a UL report. The grounding certification is really 2703. It needs to be listed to 2703. It is a proposed standard. It is not a complete standard yet, but nevertheless, officials and everyone is using that as a standard. So make sure that there is an ETL report that you can pull, or you can be shown some proof from ETL or one of the certification agencies that this product is in fact certified to, or I should say listed to UL 2703. Great. So if you're interested in future SunLink webinars, go ahead and go to www.sunlink.com/training. We're looking at always keeping our customers and folks in the industry up to date in terms of informational knowledge about mounting systems in the industry and also our own products. This particular webinar was focused on mounting systems and really the structural design of those mounting systems, what you need to consider when putting them into the project. We're looking at having another webinar very soon on the construction practices. How do you stage? What's the methodology of installing those modules? And how you should really optimize your labor around installation of mounting systems. So that's something that you'll see from us in the near future. If you have any other questions, please go to sunlink.com/largescale-GMS for our large mount ground system, or sunlink.com/ballastedGMS for the ballasted ground mount system. Any type of information, you can contact sales at SunLink, or feel free to shoot myself or Kate an email with any sort of technical questions. Thanks everyone for your time, and we'll see you soon.